All right, thanks. Hi, everybody. So team, ScaleFlux team, I can't see too much. That was a great presentation. Thank you very much. Really appreciate it. So paraphrasing team, I am not a Caliptra expert, but I'm here to give you a presentation. This is our usual, every 6 months presentation on the Caliptra Journey and where we are. I'm Andres from Google. I'm wearing a Caliptra t-shirt. So this is a very short presentation, actually. 2 minutes, 1 minute for 1.1, another minute for 2.0. This slide is mostly to talk and recap what's going on in 1.1, which is essentially released now. So if you take 1.0, we fixed the bugs, all of them. There are no bugs left to fix. And there was a pretty nice optimization done on the crypto engines, smaller area, higher performance, win-win. That doesn't always happen, but we're very happy about that. We added 2 firmware interfaces to it as well, an LMS signature verify primitive, like a direct verify primitive, and another verify of a manifest primitive. So the firmware interfaces are relatively, simpler to add, so we put them in 1.1. The main point of 1.1 was the performance and bug fixing. We are on the cusp of 2.0. That's the main topic of this presentation. I want to use this slide here to sort of present and talk about what we're doing with 2.0. So the first part here that it's important is the top left, right? That's Caliptra core. That's Caliptra as you know it in 1.0 and 1.1. So there are a couple important things happening there. We're adding countermeasures to the RISC-V core, right? We're trying to make it more resistant to fault injection attacks and to glitching. We're adding Adam's bridge, right? You saw the if you were here in this room, you saw the presentation about Adam's bridge. This is critical so that Caliptra core can support PQC, Kyber dilithium attestation, encapsulation. So those are the 2 main things that we're doing there. The other thing that the RTL team is doing is they're transitioning to an AXI bus. That's very useful, right? That's like having a better Swiss Army knife. That's one of the things that ScaleFlux pointed out in the prior presentation that they would like to see. What else is there? Those are the main things that are happening in the core, as well as a FIFO. You can see a separate FIFO channel over on the side. We'll talk about what that's for. But fundamentally, the message here is that 2.0 is going to give you a Caliptra core, which is a first-class product, long-lived. We're going to keep on supporting it. There will continue to be integrations of Caliptra core. And that one is PQC ready, right? Using Adam's bridge, etc. So we felt that although 1.0 pretty much looks like a success to us, and it's got legs, we needed to give that to the community, the 2.0 with the PQC. So that's a fundamental thing about 2.0 that we're doing, bringing Caliptra core into the PQC area and making it sustainable as a standalone product. Then you have everything else on this slide on the south of the AXI interconnect, which is some of the feedback from some integrators, which was, hey, we want a bigger solution than Caliptra core. And that's where the subsystem kicks in. So if you want to take on more things from the open source community, you can take on the subsystem. It's essentially a second RISC-V core that you see over there. It's taking a fuse controller, it's taking an I3C interface, it's piping that I3C interface through that FIFO into Caliptra core. It's meant to implement OCP recovery, right? So it's giving you the ability to do secure boot, essentially, in your SoC. So you have these 2 options now in 2.0. You can do the full thing with subsystem, or you can keep on using core as it was conceived. So that is the critical update that we wanted to give you today in this presentation. If you look at the list of APIs, 1.0, you can see, really the way to read this slide is look at the NA on 1.0, and this is what was added, right? So in 1.1, as we mentioned before, we added on firmware 2 verify primitives, the LMS verify and the manifest verify. And if you look at 2.0, you're seeing the addition of PQC dilithium for post-quantum cryptographic attestation, and the debut of lock. If you were in the storage track, you saw a presentation from Microsoft and Google, Lee and Charles, on lock. Right? So lock is using all of this hardware, including an AES block Again, something that ScaleFlux was mentioned, that block cipher is coming on board here as well. It's using all of this hardware to build a key management subsystem. It's the same Caliptra, but with different firmware. And that key management subsystem is something that we want to see on SSD controllers. So this is the way to interpret what's going on at an API level. Really, the last slide for today, this is a very short update, right? We've done many presentations on Caliptra. You've heard about it everywhere else. We want to keep it simple. The 2.0 plan, the way it's coming together right now, the hardware is reaching a certain level of maturity. We're now going to start to break it in order to fix it. All the masking that you saw, all those kinds of things, we're going to try to do. We're going to test for side channels. We're going to test for fault injection. We're going to take those core countermeasures. We're going to try to put it all together and reach an actual RTL freeze in Q1 of 25. Right? The reason why we're doing this on this schedule is that it's critical for us to land a full Caliptra core with PQC and with subsystems for those who want it, for chips that are taping in Q1 25. There's a lot of chips that are taping in Q1 25 and taping out a little bit later. That is, these are some of the partners who are contributing to it and some of the companies that are taping out chips with Caliptra. Some of them, obviously, you know, the tech founding companies, Google, AMD, Microsoft, and Nvidia, but also others. So this is the last slide. The call to action is the same that it has always been. But I really think the way the previous presentation from ScaleFlux put it was great, right? I mean, one of the things that we're really happy is that it seems we're gathering critical mass as a community. Caliptra is starting to grow its own legs and it's starting to appear everywhere, and it's starting to be a reasonably high quality open source implementation. So be a part of it, right? Ask us questions. Come to the discussions. You know, Tim's slide was so much better than this one. Come to the discussion, ask questions, etc.
So
yeah.
Do you have any certification program, and do you have any plug test? So how do you evaluate whether it's working or certifying?
I think that's the final piece. I think that's the final piece that we need to nail together this year, right? Which is a trademark certification program. We do have, we said we would have it, right, in our prior presentations, and we do have work in progress. It's a little bit tricky. We don't want to create a new FIPS. We don't want to be guardians of dozens of chips. That's not a good thing. That's a lot of bureaucracy. So it's challenging because we're trying to strike the right balance where we see good quality implementations of Caliptra out there, but we don't become another bureaucracy and we don't cause people to waste time and money. So we don't have the finished product to present to you today.
Okay, so maybe there will be an official certification program internally after we develop. Do you have a kind of a test suite so we can internally run your test cases and prove internally and show the proof to our customers and partners? Do you have that kind of program?
That is the intention. We want to give you something that you can use, something actionable, that you can believe in your own Caliptra implementation, and that you can use the trademark. Well, questions, yes.
Yeah. Thank you for what you're doing. Can you shed some light where do you store the keys, private keys for dilithium and kyber, considering the size of them and probably you need more than one key? Where do you store the keys?
Well, I mean, I actually don't know the answer, but you can ask Moshtaba. Yeah. Do you want to take that, Bryan?
Okay, so is it part of the boundary of Caliptra or out of that? Is that a piece of flash?
So why don't we, do you want, hey, take a microphone.
Okay.
Do you want to repeat that?
So his question was where are the keys stored in Caliptra? So there's a hardware key vault inside in Caliptra, and it's got key slots in there. And even the firmware that runs within Caliptra doesn't get access to the private keys. They're only held in hardware. And then we store the seed and we can do derivations, and it gets routed from the key vault directly into the hardware accelerators without any firmware interaction.
Right. Okay.
Mhm.
Thank you.
Can I
Now we
add
got some more.
a note here?
Can I ask one question?
1 second. We've got a follow-up
Yeah.
question.
Just actually to complete Brian's actually comment, instead of we have on-the-fly private key, we don't actually store the private key, and we use actually the seed to regenerate the private key whenever we need. That's actually what we do in the Caliptra.
What I understand that Caliptra provides the baseline security, and it can be integrated with any device. Now, in the data center ecosystem, we have a number of devices going into the server platform. So are we going to make it mandatory to implement Caliptra in all the devices? Because I was looking at some other specifications, other work streams, where they have not mentioned, like they have mentioned you need attestation, but they have not mentioned what kind of attestation, because there are so many possibilities to implement an attestation, right? You can use TPM code, you can use EAT token, or you can, if you have a proprietary implementation of DICE and so on. So how do you ensure a homogeneous attestation framework in the data center?
I think those are several questions into one, right? So I'm going to touch on some points we've touched on before. When we set out, we began with Caliptra, we understood that we couldn't possibly boil the ocean all at once. So if you look at the way we've attacked the space, we've gone after CPUs and accelerators first, and we're slowly growing into outer rings of data center devices. We're now onboarding BMCs, we're onboarding SSDs, right? We're moving at a measured pace, right? We're not going to go and ask a DDR vendor to integrate Caliptra. If they want to do it, we're not going to stop them, right? But we're not necessarily going to spend our own energy there just yet. Caliptra is meant to be a reference implementation, and it's meant to be a community implementation. It's meant to be open source, and it's meant to be high quality. If we achieve all of our goals, then yes, there's a very reasonable case for Caliptra to be everywhere, right? Mandating Caliptra, I don't think we want OCP to mandate Caliptra. That would be somewhat monopolistic. On the other hand, we see a lot of implementations as customers that we do not like and do not work for us. And the reason we set out to do Caliptra was to address that problem. So it's a very nuanced answer, right? It's not a black and white answer, do Caliptra or you're out of business. That's no one's intention.
Yeah.
It's a very nuanced answer. We're trying to solve a very specific problem through an open source community approach.
So, because my question was regarding the different work that is ongoing in OCP, for example, BMC security or some power supply as MCRPS specification and all that. So do we need to, are we planning to mention Caliptra, or it is going to be open that you use whatever you want for attestation, for instance? Or is nothing
For a power supply,
or by BMC security, for instance, or
BMC suppliers, they can take the stage if they want to say what they're doing about Caliptra, right? But I think that's trending very well.
Okay, thank you.
Yeah, thank you for the question.
Thanks for the presentation. My question is, the Caliptra's, the functional scope was root of trust for measurement.
Yeah.
Does that continue to be the same, or is there
Correct.
extended scope in the Caliptra 2.0, like the root of trust for recovery and update? That also comes into that, or is it, because the Caliptra 1 specifies for various reasons that is not included in that, and then it is expected to be a separate chip. Is there any change in that scope, or is that continues?
Okay, so Caliptra 1.0 is only an RTM. It's called Caliptra Core.
Right.
In 2.0, we offer choices. If you integrate a Caliptra Core, or if you just want to integrate Caliptra Core, you can continue to just use Caliptra Core, and Caliptra Core continues to be a first-class product, and it's an RTM. However, there is a subsystem. If you want to broaden the scope And if you want to utilize the Caliptra subsystem block to bootstrap your CPU or your whatever, your SoC, whatever it is, right? Then you can do that too.
I see.
So you have choices.
So then in that case, it kind of replaces the need for separate chip for the root of trust for update and recovery. Is that the path you are going towards?
Not completely. I mean, we should talk about that in the context of the, what do we call it? The admissible, modular security architecture that we presented at OCP in terms of what we're hoping to achieve. I mean, it's not turtles all the way down, right? At some point, there is a device that you need to rely on that is nothing but a security device inside the platform. So, and there are options for that are open source as well, right? We're thinking about things like OpenTitan and others. But it's really difficult to get to a point where you have a platform without a discrete root of trust device, or platform root of trust as it's called in other types of terminology.
Thank you.
Yep, you're welcome. Thanks for the question. Think we're good? Thanks everybody. Thank you very much.